Welcome to lecture number 13 of fuzzy sets, logic and systems and applications. In this lecture, we will cover the remaining properties of the fuzzy sets. So, we have already discussed some of the properties of classical and fuzzy sets in the previous lectures, and these are the properties that are covered. So, I will just mention here law of contradiction for fuzzy set is discussed, and then law of excluded middle is also discussed. Idempotency property is discussed, involution is also discussed. So, we see that we have covered so far 4 properties as mentioned here with respect to fuzzy sets. Now, remaining properties will be discussed, we will try to cover in this lecture. So, we will start with the commutativity property. So, as we know, for crisp sets A and B, A union B is equal to B union A, and this is the commutativity property for union. So, let us now see what is happening when we take fuzzy sets instead of crisp sets. So, if we take 2 fuzzy sets A and B, so let us see whether we get A union B is equal to B union A or not. Of course, it is written, so we will be getting these 2 equal. So, let us see what is happening and how are we getting this commutativity property for union satisfied. So, if we take an example here where we take 2 continuous fuzzy sets A and B. Here fuzzy set A is a triangular fuzzy set, this is fuzzy set A which is triangular as we see, and B fuzzy set is a Gaussian fuzzy set here as we see. So, we call this as B fuzzy set. So, now let us see whether A union B is equal to B union A or not. So, if we take A union B here, so we apply this condition where we take the max of all the corresponding membership values from fuzzy set A and B with respect to their corresponding generic variable values. So, if we do that, we find A union B as this. So, here, so this is nothing but A union B. So, we have already discussed enough as to how we get the union of 2 fuzzy sets. So, this way we get here after applying this condition, we get A union B as mentioned over here. Now, let us see what are we getting as the outcome when we take B union A. So, if we take B fuzzy set here first and then we take A fuzzy set, and then we see here that if we take B union A, we are going to get this fuzzy set as B union A when we apply this condition. We take max of mu B and mu A. So, this way we see that what we are getting here is A union, this is A union B, and this B union A, and if we see here both the outcomes are same. So, we can clearly say here that the commutativity property for union is verified or satisfied for fuzzy set A and B, and this is written as A union B is equal to B union A. And please note that this commutativity property for fuzzy sets A and B are satisfied. Now, let us take another example where we have two discrete fuzzy sets. So, if we take here A fuzzy set as a discrete fuzzy set and B also a fuzzy set which is discrete fuzzy set. So, let us now try to see whether A union B for discrete fuzzy sets is equal to B union A or not. Of course, this is going to be equal, but let us see how are we going to get this verified. So, here we have fuzzy set A, discrete fuzzy set A, discrete fuzzy set B, and see here if we find the A union B of the two discrete fuzzy sets, we are getting this, and when we are taking B union A, we are getting this as the outcome. So, we can clearly see that all the elements of A union B and B union A are same. So, we can clearly say here that these two fuzzy sets are equal. So, when these two fuzzy sets are equal, we can very easily say, or we can say that the commutativity property for union is verified. Now, on the same way we can define the commutativity property for intersection. So, here when we talk of intersection, so let us first see what is this for crisp sets. So, if we take crisp sets A and B, so when we take crisp sets A and B, this property is satisfied, means A intersection B is always equal to B intersection A for crisp sets A and B. Now, let us see what is happening for fuzzy sets A and B. So, here also it is equal, means when we take two fuzzy sets, A intersection B is always equal to B intersection A. So, let us see how we are going to get this verified. So, if we take an example here, in this example we have two fuzzy sets as we have taken in the previous example. So, we have taken the same example here also. So, we see that when we take A intersection B using this condition, we take min of all membership values corresponding to the generic variable values for A fuzzy set and B fuzzy set. So, A intersection B we are going to get like this. So, this is what is the A intersection B, which is represented by the red color fuzzy set. So, this is what is the outcome. And let me also make it very clear how do we get that here. So, you see here that we have this as B fuzzy set, this as A fuzzy set, and when we take min of the respective membership values for corresponding generic variable values, we get here the portion which is represented by a red color plot. So, we see that this is what is we are going to get as A intersection B. Now, when we take V first, when we take B first and then A, of course, these B and A are two fuzzy sets. So, if we do that, let us see what is happening. So, here also we have B fuzzy set and then A fuzzy set, and then when we apply this condition, the condition for intersection. So, when we find this, we are also we get again the same portion of the fuzzy sets. So, B intersection A is going to be the same as A intersection B. So, this way we can say that commutativity property for intersection is verified for fuzzy sets A and B. Now, again if we take the discrete fuzzy sets A and B, here also we see that if we take A intersection B here for fuzzy set, for discrete fuzzy set A and discrete fuzzy set B. So, we see that we have A intersection V as the outcome. So, this A intersection B is 0.7 by 1 plus 0.3 by 2 plus 0.1 by 3 plus 0.5 by 4 as the outcome. Now, let us see what are we getting when we take B intersection A. So, this way we see that we are getting the same outcome as we have gotten for A union B. So, all the elements remain same, and then and hence we can always say that A intersection B is equal to B intersection A for discrete fuzzy sets also. And hence we can say, since we have already checked this condition for continuous fuzzy set A and B, and here in this case also for discrete fuzzy set we have checked. So, we can say that commutativity property for intersection is verified. Now, let us go to the associativity property for union. So, as we already know that for crisp sets A, B and C, we have this equality as the associativity for union, means A union B and then union C is always equal to A union B union C. So, for fuzzy sets A, B and C, this condition also is satisfied. So, let us now see how is it happening. So, if we take an example here again for the associativity property for union, we take a fuzzy set A, continuous fuzzy set A, continuous fuzzy set B, and then the third fuzzy set, continuous fuzzy set C. So, we see that if we take the A union B here, where A is this fuzzy set and B is this fuzzy set. So, we are going to get A union B like this. So, this is what we are going to get, means we are going to get the max of all the respective membership values corresponding to the generic variable values of both the fuzzy sets. So, this way we can say here that we are getting A union B like this. Now, since we already have A union B, now take the we use this and take the union with C. So, let us see what is happening. So, we have C fuzzy set here. So, A union B and union C means A union B union C, we are going to get it like this. So, if we apply the same criteria, we are going to get this portion as the A union B union C by applying the same max criteria. Now, if we take B, the union of fuzzy set B and C, we are going to get this as the outcome, means B union C is this outcome. And if we take the A union B union C, we are going to get here this as the outcome by applying the same max criteria. So, we can clearly see here that these two outcomes are same in both the cases, means either we take A union B union C or we take A union of B union C. So, we can clearly say that the associativity property for union is satisfied or verified for fuzzy sets A, B and C. Now, the same can be tested, same can be checked by taking the discrete fuzzy sets A, B and C. So, if we take these three fuzzy sets A, B and C, so we find here, if we directly go to the outcome of the A union B and then union C, we are going to get this as the outcome. So, this is what is the outcome. This is a fuzzy set, a discrete fuzzy set. So, let me read the element of this fuzzy set: 0.8 oblique 1 plus 0.7 oblique 2 plus 0.7 oblique 3 plus 0.9 oblique 4. And when we find the A union, the fuzzy set which we have got as a result of B union C, if we take this thing, we get the outcome here as 0.8 oblique 1, 0.7 oblique 2, 0.7 oblique 3, 0.9 oblique 4. So, if we look at these two fuzzy sets, these two outcomes, we see that these two are equal, these two are same. So, then it is very clear that A union B union C is equal to A union B union C, means the associativity property for union is satisfied or verified. So, this way we have checked the associativity property for union. Now, let us do the same thing. Let us now check the associativity property for intersection. So, for crisp sets A, B and C, this property, the associativity property for intersection is satisfied, and for fuzzy sets A, B and C are also satisfied, but we need to verify by taking some examples. So, let us here also take few examples, two examples. First example is with the continuous fuzzy sets, and the second example is with discrete fuzzy sets. So, the first example is here, and here we take 3 fuzzy sets A, B and C, and let us now try to see what are we getting when we do A intersection B intersection C. So, what does this mean when we say A intersection B intersection C? It means that we are going to get a fuzzy set as the outcome of A intersection B, and then whatever we are getting as the outcome, we take the intersection of this fuzzy set with the third fuzzy set C. So, A intersection B is here. So, this is what we are getting as a result by applying this condition, the min condition. So, this is A intersection B. So, this is a fuzzy set basically, which is, by just looking at it, we can say that this fuzzy set is a subnormal fuzzy set, and when we take the intersection of this fuzzy set with C fuzzy set, the third one, the third continuous fuzzy set, which is C. So, it is here, and if we do that, let us see what are we getting. So, if we apply this, the min condition, we are getting this fuzzy set, which is again a subnormal fuzzy set, and this is the outcome of A intersection B intersection C. So, this is how we are getting the outcome of A intersection B intersection C. Now, let us try to verify, let us try to get B intersection C first. So, B fuzzy set is here, we and please remember that this is please note that this is a continuous fuzzy set, all these fuzzy sets A, B, C are continuous fuzzy sets. So, B intersection C we are going to get like this. So, this is our B intersection C. Now, since this is a fuzzy set, again by just looking at it we can say this is subnormal fuzzy set. So, if we take this fuzzy set, or we see if we take the intersection of this fuzzy set and A. So, let us see what are we going to get. So, here we have A. So, here we have to follow the sequence. So, we have A fuzzy set first, we take the subnormal fuzzy set B intersection C, and when we find A intersection B intersection C, let us see what are we going to get. So, when we apply the min condition, we are going to get this as A intersection B intersection C. So, just by looking at this, we can clearly say that these two fuzzy sets are equal. So, this way we can say the associativity property for intersection of three fuzzy sets A, B and C are satisfied. Now, let us see what is happening when we take the discrete fuzzy sets. So, here we have three discrete fuzzy sets A and A, B and C. These three are discrete fuzzy sets, and if we try to find here, I am going directly to the outcome of A intersection of B and then take the intersection with C. So, we are going to get a fuzzy set, a discrete fuzzy set, which is 0.4 oblique 1 plus 0.3 oblique 3 plus 0.1 oblique 3 plus 0.5 oblique 4. So, let me repeat it. So, we are going to get the outcome as 0.4 oblique 1 plus 0.3 oblique 2 plus 0.1 oblique 3 plus 0.5 oblique 4. So, this is what is the outcome that we are getting as the intersection of A intersection B and C. So, now when we compute the intersection of A and B intersection C. So, this is what we are getting when we apply the Min criteria. So, if we look at all the elements of these two fuzzy sets, we find 0.4 oblique 3, 0.3 oblique 2, 0.1 oblique 3, 0.5 oblique 4, all are separated with plus sign. So, we see that all the elements are same as we have here. So, this way we can say that if we take intersection of A intersection B and C, and if we take the intersection of A and B intersection C, both are equal. So, this way we can say the associativity property for intersection is verified for all the three discrete fuzzy sets also. So, this way we understand that the associativity property for intersection are all satisfied for fuzzy sets also. So, in today's lecture we have so far covered the following properties of fuzzy sets: the commutativity property for union, commutativity property for intersection, associativity property for union, associativity property for intersection. So, we have covered all these four properties for the fuzzy sets, and we will stop here for this lecture, and in the next lecture we will cover the remaining properties of fuzzy sets that we have already seen listed. Thank you.